All right, welcome ladies and gentlemen to week number 81, Open Live Q&A. My name is Mr. McLogan, and thank you so much guys for joining me in tonight. Apologies for a little bit of some issues last night, but hopefully everything is going to go just fine for this live stream. So kind of like what I did last week, I wanted to kind of, let you guys know exactly the questions that we're going to get to, and then we'll kind of get right to those. And then if you guys have any questions after that, then I'll be more than happy to kind of hang around and stay with you guys for a little bit. Now, just remember, all of these questions that I am going to be answering tonight have been pre-submitted. They've been submitted on the link in the chat. If you can see, I pinned the message. Go ahead and go to there and submit questions as we are beginning to get a little bit closer to the school year. And so if you do have questions that are coming up and you like me to answer them, then feel free to go and submit them. I like to pick, anywhere from 3 to 5, and that I'll be addressing on the live stream. So Maliki, M&M, Alyssa, and Greg, and Jay, and Andre, it's great to have you guys on. Thank you so much for coming in. Yes, Andre, I can. In addition, well, let me get through this. So you can go ahead and feel free, any questions you guys have, submit them. However, I only go live once a week. So if you are looking for a little bit more immediate help, or maybe you have a lot of questions, also take a look at the Discord link that's also in the pinned message. Therefore, you guys can go and join a free community, get help, answer some questions, help other students with their math. And then, it's just an open community for you guys to be able to get math help. So I'm hoping that can be a great resource for you guys this year. Also, I wanted to let you guys know that if you are taking pre-calculus, I have just released, and you guys are kind of getting the first dibs on it because I have not officially announced it yet, or at least made a video about it, which I will be doing soon. But if you are taking pre-calculus, or maybe you just took algebra 2 and, you're like, hey, I wonder what's going to be, what are some things I need to know for pre-calculus? I just opened up and my get ready for pre-calculus kind of course. So this is something that I give to my students over the summer to prepare for the pre-calculus course. And there's some diagnostics tests in there. There's a lot of problems, a lot of answers, a lot of videos of me working through the solutions. So if you're definitely taking pre-calculus, I would highly recommend going through it and just getting yourself prepared, because I think we can all agree the way that the last year and a half have been, education has not really been the same. And some people have better experiences than others. But if you kind of need something to make sure that you have learned what you need to learn and you are prepared for pre-calculus, then definitely go ahead and check it out. And again, it is absolutely free. Link is in the chat, and I will pin that by the end of the night as well. Let's see. Clevy and Mohammed, I'm 12 years old. I can do calculus. Well, that's awesome. I think that is great. I think everybody should be doing a little bit of calculus and stuff like that. I think that's awesome. And Abdullah from Uzbekistan. Well, awesome. Happy to have you on. Manuel says, I'm taking Algebra 1 final. What are some things that you think are really important? Whatever your teacher has gone through. I mean, I do plan on having some things going for you guys. Some more resources for other courses, just besides pre-calculus, but those things will be coming up. But whatever your teacher has gone over with you, I would highly recommend, just making sure you study for that stuff, guys, for sure. All right, so let's go and see what questions we have going on tonight, guys. And again, I'm going to get through these questions. Then if you guys have any other questions, feel free to hang out afterwards, and I'll be happy just to kind of address any other question you guys have. So we're going to start with some magnitude and direction. We're going to look at the resultant vector for vectors. We are going to rationalize the denominator. We are going to talk about the remainder theorem, and then the student did not tell me what their question was. I'm assuming it is writing the equation of a line. All right. So let's go and get into that. All right. So for the first question, and again, actually I addressed this last night in the live stream, but last night's live stream stuck. I don't know what was going on. But anyways, so first thing you want to do, guys, whenever you have a word problem, and I don't really usually like doing word problems on my live streams, but I decided for this student that I would do it. So you're welcome. All right. So the first thing we're going to want to do is just draw a picture. All right. So the reason why I kind of drew an axis is because I saw this 50 degrees from the horizon. So I'm doing this in standard form, okay? And typically when we're doing something in trigonometry, pre-calculus, or physics, we want to be able to have these angles. We're going to be using them in standard form. All right, so Jake is pushing Kyle to the right. Okay, so here's Kyle, right? All right, so now we have a Jake and we have a Joseph. So I'm going to call Jake JK. All right, now he's pushing Kyle to the right at 100 newtons. So we're going to have like that vector going right there, and that's going to be 100 newtons. All right, then it says Joseph is pulling Kyle's arm up and to the left at an angle of 50 degrees from the horizontal. So that 50 degrees is going to be like right there, right? All right, so we're going to say, I don't know, something like that. And I'll call him JS for Joseph. Now, again, it's really important for us to understand that's going to be at what, 140 newtons. Okay. So what we're doing is we're looking for the resultant vector that's actually being applied to Kyle. Okay, so we have both of these two forces are acting on Kyle at the same time. So basically, like, what is the resultant vector? And the way we can look at this visually, and to do that, what we're going to do is called the tail to head method. So to do that, all we're going to simply do is take one of these vectors, and it doesn't matter which one you do, and you're just going to add it to the tail. So you're going to take basically the tail of one vector and add it to the head of the other vector. Okay, so I'm trying to do the best that I possibly could here, right? If I just kind of move that up. Okay, so I took this vector and I moved it up. Now this is what we call our resultant vector. So when I go from my original K, right, that's what we call R, which is going to be our resultant vector. So that's what we need to find. Not only do we need to find the force of this, but we also are going to want to, actually, what does it say? We want to find the magnitude and the direction. So we got to find the magnitude of this, so the force, as well as the direction, okay? So how do we do that? Well, the first thing we want to do is calculate these or write these as vectors, okay? So to do that, we're going to use what we call the magnitude and direction of vectors. And we're going to use a simple formula here. Cosine of theta, sine of theta. Okay, so we have the magnitude times cosine of theta, sine of theta. And that's whenever you have a vector, when you have the direction of that vector and the magnitude, we're going to want to use that form for a vector rather than component form or linear combination. All right, so we have, let me see. Let me get that out of the way, actually. Huh, that's interesting. Okay. All right. So in this case, we have JK. All right. So let's do Jake first. Okay. So Jake has a magnitude of 100 newtons, right? So we're going to say 100. And then his angle is going to be like 0 degrees. If you think about angles in standard form, that's going to be at 0 degrees. So let's say this would be a cosine of 0 degrees and a sine of 0 degrees. Okay, and then we have Joseph. Now Joseph is a little bit different because we don't want to use 50 degrees, right? What we want to do is use an angle in standard form. So that's going to be 130 degrees. Okay, so we're going to say, the magnitude is 140, and that's going to be times the cosine of 130 degrees, and that's going to be sine of 130 degrees. Okay, now again, remember the whole idea is we're trying to find this resultant vector, right? So we're basically trying to combine them together. So a couple things with operations with vectors, we can distribute or we can multiply this magnitude times both of these components. All right, so our resultant vector is going to look something like this. So when we want to find the resultant vector, all you're simply going to do is add the horizontal components with the horizontal components and the vertical components with the vertical components. So I can distribute these to both of them, and what I'll have is 100 cosine of 0 degrees plus 140 of cosine of 130 degrees. And then I'm going to do the vertical components. So I'll do 100 of sine of 0 degrees plus 140 of sine of 130 degrees. Okay, so that's going to be what my resultant vector is. Now I do have a calculator, so I'm going to go ahead and calculate this for you. Make sure when you're doing your calculator that it's in degree mode, all right? And I'm just going to calculate these, and I'm just going to round these. Cosine 0 is 1, right? So that one's kind of easy. Plus 140 times the cosine of 130 degrees. All right, so that is going to give me a component here of 10.009. I'm just going to truncate to the nearest thousandth. All right, and then we have sine, 100 times sine of 0. Well, sine of 0 is 0, right? So that's going to be 0 plus, let's see, 140 times the sine of 130. And that's going to be 107.246. Okay, just going to deal with my truncated answers. All right, so that's your resultant vector. Now, again, that's not the question, though. The question was, what is the magnitude, right? So the magnitude of R, so we're going to use that formation, is basically that's going to be the square root of 10.009 squared plus 107.246 squared. So what we're simply going to do is just take our last answer, square that, and then add that to 107.246. And then we'll take the square root of that answer. And we get 14. That's not right. Something went wrong. Oh, I forgot to square that. Dang it. Let's redo that. That's got to be squared. There we go. All right, so then I get 108.28. So let's see, 108.288. And then again, remember that's in newtons, right? So the important thing is let's see if that makes a little bit of sense, right? So we're having 100 newtons is being pulled directly to the right, and then 140 to this way. So does it make sense that that'd be pulled at like 108 newtons? Yeah, because like you have this 140, like that's canceling a little bit, right? But that's going up. So 108 like sounds about right. I'll take that. And then let's look at the angle. Or I'm sorry, the direction. So when we're looking at the directions, now what we're basically going to be looking at here is we want to be able to find this angle, okay? So we want to find that angle theta. So again, with trigonometry, basically all we simply want to do is be able to say, well, that's going to equal the tan of that angle of theta is going to equal to 107.246 divided by 10.009. Okay, so theta equals tan inverse of that, 107.246 divided by 10.009. All right, so let's see what that is. So tangent inverse of 107.246 divided, tangent inverse of 107.246 divided by 10.009. And that is 84.66. So 84.668 degrees, right? And again, does that make sense? Like, yeah, that does, like, that looks like 84 degrees, right? It's maybe a little bit higher, but you can see like, yeah, that makes sense. So there you go. Hopefully, all right, let's get on to question number 2. So question number 2 is going to be rationalizing the denominator. So our goal in this case is to eliminate the radical, okay? So it's really important for us to understand, like if I have the fifth root of x to the fifth, that gives me x, right? That's good. We want that, all right? But if I have the fifth root of like x to the fourth, that's no good. I can't do anything with that, right? So that's bad. Okay. So that does not equal like x. All right. So what we want to do is we want to get the power of whatever our radicand is to be the same as the index. And that will allow us to eliminate our square root, or our root, our radicand. So what we can do is if you look at this, x plus 3 is our radicand, right? That's really raised to the first power. So the only way I can multiply this is if I multiply this by x plus 3 to the fourth power, right? Because remember, the product of, or the rules of radicals allows you, when you multiply a radical times a radical, you multiply the radicands, right? As long as the index is the same, you can multiply the radicands. Now, when you rationalize the denominator, whatever you do in the denominator, you have to do in the numerator to produce equivalent fractions. All right, so you can't really do anything here. You can't take a number, multiply it like inside of a radical. So that's just going to be exactly as it is. And that's going to be x plus 3 to the fourth. Okay. However, in the denominator here, right? So x plus 3 times x plus 3 to the fourth is going to be x plus 3 to the fifth, right? So that's going to be the fifth root of x plus 3. Oh, come on. To the fifth. Hopefully you're not getting too much buffering. Let me know in the chat if it is. I apologize. I don't know. My internet, something's still going on with my internet. I'm not sure what the deal is with that. But let me know if you're getting some buffering on this, because I do apologize for that. That's kind of the same problem that I had last night, except last night I just got kicked out. So then obviously you can see the fifth root of x plus 3 to the fifth is just going to be x plus 3, right? Kind of the same thing we did here. So that's going to be 3 times the fifth root of x plus 3 to the fourth divided by x plus 3 to the fifth. Awesome. Thank you for letting me know, Shen. All right. Question number 3 says, can you briefly generalize the concept of the remainder theorem? Andy, I will be getting to your questions. I'm almost done. I only have 2 more questions left. So if you have any more questions, let me know at the end and I'll be happy to address them. All right. Question number 3, briefly concept of the remainder theorem. All right. Well, so I'm just going to pick a easy problem then, if that's okay with you. So if I have a polynomial, x plus 1, let's actually go through. Let's go through it all. So x plus 1, let's say I say x plus 1 divides into x squared plus 3x minus 7. Okay. All right. So let's do long division, synthetic division, and then the remainder theorem. And you can kind of see why something might be helpful. Okay. Now in algebra 2, we typically say, hey, divide this polynomial into this polynomial. And you're like, okay. So remember to do that. You take the first term, x, how many times to divide into x squared? It goes in there, x times. Then you take x times x, which is x squared. And then you take x times 1, which is x. Okay. Then remember you subtract the rows. Okay, that goes 0, 3x minus x is going to be a 2x. Then you say, hey, how many times does x divide into 2x? And you say that becomes 2 times. 2 times x is 2x. 2 times 1 is going to be a positive 2. You can bring down this negative 7, right? And then again, we subtract our rows. Okay, and we say negative 7 minus 2 is going to be a negative 9. Now again, since my x plus 1 does not evenly divide into x squared plus 3x minus 7, we say this is our remainder. Okay, so that's a little review here from long division. Now, once we get into a little bit more complicated polynomials, we like to also work in synthetic division. So for synthetic division, we don't use the factor. What we use is the general, the potential 0 of the polynomial, which would be negative 1. We basically set our factor, set it equal to 0, and solve. So that's how I got the negative 1. And again, this doesn't work for the remainder, or the synthetic division doesn't work for all division of polynomials, but it does work for a lot. Okay, and it also is very helpful. So to do this, all we're going to do is now take their coefficients. So we're going to do 1, 3, and negative 7. I know this question is a remainder theorem, but I'm getting to that. All right, so if I bring this down, so I bring down the first number 1. 1 times negative 1 is negative 1. That becomes a 2. 2 times negative 1 is a negative 2. That becomes a negative 9. And again, you can see where I'm getting my answers, x plus 2 plus 2x, and then this is my remainder. Okay, so both problems when I did division produced, and actually let me just see where you got this. So it's x plus 1 equals 0, x equals negative 1. Okay, okay. So this is very important, this number. Okay, so we use this right there. And for the remainder theorem, what the remainder theorem basically says is, well, actually, I don't want to say this because now I'm paraphrasing, which is the thing, but if you take your factor, okay, and if we take this value, a lot of times we call it k, right? But if it's really like a potential 0. So if we take, let's pretend here is my function, like polynomial, and if you plug in negative 1 into that polynomial, that's going to give you what the remainder is. So when I plug in a negative 1, so if I have my function here is, let's just call this f of x equals x squared plus 3x minus 7. If I plug in f of negative 1, and again, where did this negative 1 come from? It came from here, right? It came from the factor set and equal to 0. Okay, so whatever that number is, which you would use for synthetic division, if you just plug that number in, that's going to give you, this is going to evaluate to your remainder, the remainder of the polynomial. So again, if it's 0, then that's obviously the remainder. So negative 1 squared is 1, minus 3 minus 7. Well, guess what, guys? That equals negative 9, which is exactly our remainder. Okay, so that's what the basically, synopsis of what exactly the remainder theorem is going to give us. The reason why this is very helpful is, what if the question was like, hey, is something a zero of a polynomial? Well, again, then what you can do is just check the remainder theorem and see if you get zero. If you get zero, then obviously the factor or then that's a zero of the polynomial, right? So it's a quicker way sometimes than doing actually the division to determine if something evenly divides into the polynomial. All right, question number 4. So again, I'm assuming this is writing the equation of a line. So a couple things we want to do is when we're writing the equation of a line, I'm assuming this is going to be in slope-intercept form. So remember that's y equals mx plus b. Okay, that is our more common term. And the reason why this is a nice form to be able to graph from, just because it makes life very easy when graphing. But we got to remember what the components are for this. So b represents our y-intercept. That's going to be where the graph crosses the y-axis, which you guys can see is at 4. Right? Okay. And then m represents our slope. And that's basically going to be the rise over run between any 2 points on the graph. So again, when you're looking for a point on the graph, you're looking for where the line or when the graph crosses like an X and a Y kind of grid point. You can see right here. Okay. So our slope is basically going to be like, what do we need to go from one point to the next? How do we do that? Right? Well, there's a couple of different ways we can calculate this. And this is why sometimes slope gets very confusing. I think you guys would all agree that this coordinate point is 0, 4, right? So we could say B is equal to 4. Okay. That's the value where the graph crosses the y-axis. All right. Now slope though sometimes gets confusing because you could say, well, from the left dot to the right dot, I can go up 3 over 1, right? So you can say 3, 1. And then some people say from the right dot to left dot say, well, you could also go down 3 to the left 1. Now again, it's important for you to remember though, the slope is rise over run. So 3 over 1 is the same thing as -3 over -1. Both answers are going to be 3, right? So it really doesn't matter if you're going to go from left to right or right to left. And you do want to be flexible in this scenario of how you're going to do that, because sometimes when we're doing graphing, it is helpful actually to read it from right to left. So in this case though, we have my m is going to be 3. So the equation of the line would be y equals 3x plus 4. And there you go, ladies and gentlemen. So that is it, guys. The 4 questions. I will have these timestamped for you guys and with like all my live streams. If you are joining a little bit late, just to kind of give you guys a quick little review, these are all questions that were submitted to me earlier. So I know people always like to ask questions, at the end of the stream, and we'll kind of see what other initial questions I get to. But if you guys do have any questions, feel free to join the link. I did pin it in the chat that you guys can definitely go ahead and submit your questions. And, I like to be able to get to 3 to 5 questions, each and every week to answer your questions for you guys. However, I know that I'm not going to get to everybody's question. So if you do have a question that I do not get to, then feel free to also go to the Discord link, which is also pinned in the chat. And therefore, you guys can submit your questions. There's people that are students just like you, willing to help each other out and answer your questions. Hopefully, that can be a great resource for you guys this year. Also, for all of my pre-calculus students, I also have a pre-calculus, getting ready for pre-calculus course, which is completely free, and it's basically designed to get you guys ready for the upcoming school year. So if that is something that you are taking this year and you are like, hey, I need help with stuff in pre-calculus, or maybe you took Algebra 2 and you're like, I forgot everything, then this might be something good for you as well. So anything, it's mostly there's some diagnostic tests inside of there. There's a lot of practice problems for you to get ready. So it's a really calculus as well. It'd actually be great for college algebra as well. It's designed for pre-calculus, but anybody that needs a little bit more help in the kind of the algebra realm, and a little bit, maybe a little trick, barely a little trick, a little geometry, it will be very helpful for you. So hopefully you guys can go ahead and use that link. Again, it's absolutely free, and go ahead and check that out. All right, let's get any more questions. Get a little bit longer. I'm trying to shorten my streams as much, not do as full hours, but I'm happy to answer any questions you guys have. Well, happy to help you out, Sam. Thank you. I have a GD. I struggle with math, but I hope I pass my tests. You got this, Lawfield. You got this. Hey, you probably taught me more students. Well, thank you very much. I greatly appreciate that. Thank you, Strawberry Sprinkles, and I love your name. That's awesome. Oh, that's awesome. Hey, Keyshawn McLeod. Good to have you on. All right, quick question. All right, Andy says, are there any textbooks for grade 10 math or just merely resources? It really depends on, there's, math doesn't really, after you kind of get out of lower and middle school, really then it kind of depends on what you're able to take. So I wouldn't really say math doesn't correlate as well with like what grade you're in. It really kind of correlates with your, what your ability is. And again, like I say this very important for you to understand, like if you're not at a certain ability at a certain time, that's okay. Like you can still catch up and it's perfectly fine. So don't feel bad if there's people that feel like they are above you in your math. If they feel like they're doing calculus in 10th grade and you're like, I'm barely doing pre-algebra in 10th grade. That's fine. It's okay to continue working hard and do the best you can do. And there is no race to be in math. And so I think it's important for you to understand that, it really kind of depends on where your ability is in the 10th grade. Keyshawn, if you email me a question, emailed me a question. Don't email me questions. I get a ton of email, but if you have feel free to add into the link and go ahead, or the link that's pinned, and therefore you can go and submit your questions from on there. Hey, Brian, do you have a stream ID? I do. Stream ID, but not going to show it. Does pre-calc cover all the trigonometry needed for calculus? I would say most pre-calculus courses, I would say, would cover all the trigonometry that you're going to need for calculus. I mean, at least like Calc 1 and Calc 2 from in there. But yeah, I think as far as the basics of what you need for calculus, yeah, pre-calculus is going to give you exactly what you'd want from there. Can you help mathematical induction? It's been a long time since I handled any with the mathematical induction. So it probably wouldn't be a great explanation for you guys on there, to be honest with you. It's been a while. Okay, who's the baby? I don't know what you know. Practice the whole second semester of my pre-calc class was dedicated to trig, and it was definitely enough to parent. Yeah, I would definitely. I mean, that we teach, basically half my classes on the trig. I would say like in calculus, like, getting into like the inverse functions, I don't really teach it as much from on there. And I know that's a little bit more pushed on like the Calc BC, but I'd say for the majority of students and majority of courses, you're going to get everything you need in a pre-calc course. No, I cannot help with the mathematical induction. Or at least now, it's been way too long since I did that. Yeah, it's okay, Draza. Where can I access this course before going into pre-calc you just mentioned? Well, I posted a link. I can post it again for you if you're interested. Go ahead and check it out. How old are you? I am 37 years old. So, yep, all of the fun stuff. All right. I'm done with my high school and still watch your streams. Well, thank you, Sam, for joining in. I greatly appreciate you stopping in and just saying hello. It's kind of like the same thing. I always tell my students like, hey, like once a student, always a student. Always stop by, say hello in the classroom. I always love hearing back from people that, especially that they're finished with their math or finished with whatever they're taking. It's always a great feeling to, come back. I'll be planning on making my streams for many, many, many more Sundays. So I really wish you the best, and always happy to have you come back on. Keyshawn, I will get to logarithms. Make sure you submit your question. I didn't go back and check the questions. Once I kind of get my questions ready for the week, then that's what I'll do. So I'm not going to be adding any more questions, but feel free to submit them. I thought you were way younger. Thanks. I guess I'll take that. Either way. All right, guys. Well, that is it for this week. And I will see you guys next Sunday. Had a little bit. Okay, Keyshawn, I'll get to your question next week. I make sure you pre-submit your questions before the live streams every Sunday. All right. And I'll get to them. Our series covered in Calc 1. Not that I am aware of. Mostly series are going to be calced in the BC for like Calc 2. Yep, as far as I'm aware. So I'll be done with the course by then. Well, you'll be okay. Yes, that is correct, Mike Red. Keyshawn, you're going to be done with your course. That's everything. Let me see if I can answer your question real quick, or if it's going to be too much. I already got 5 questions. Jeez, oh man. All right. Now it's just interesting to see what you submitted to me. No, I'm not going to be able to answer your... That's going to take too much time for me to thinking through this problem. I'll go ahead and take a look at it for next stream. See if I can be able to help you out with that. But yeah, it's something I'm going to have to read through. So anyways, guys, I will hopefully have a nice night. And why do you guys do that? All right. Jeez, oh man. All right, guys, you have a great rest of your week, and I'll see you guys next week. Cheers.